But when you are given something like this, you can also first start with minus 3 over 5, né? And then use the soccer tool. If I say the cos of 2a, so my angle is 2a, and I'm given as minus 3 over 5. So since the angle is 2a, I don't know which quadrant the angle is 2a. So this is what I'm going to do. To decide which quadrant we need to put this on, this is what you're going to do. Going to do your Cartesian plane, right? And then you check cos 2a, it's negative. Where is cos negative? If I say all students take coffee, this tells you that the cos it's negative in quadrant 3 and quadrant 2. Then when you are done, you're going to say, where is this interval? They say between 180 and 0. If this is 0, this is 90 degrees. This is 180, and then we have this part. Okay, so now you're gonna check. You're going to mark the quadrant where A is. Understand? Where is the quadrant? The given interval is between 0 and 180, which is quadrant 1 and 2. The quadrant that has two ticks, that's where you're going to draw your diagram. Ne? So this is what I'm going to do for my diagram. I know that it will be in quadrant 2, and then there is my angle. So it will be in this quadrant. This angle is 2, it's 2a. And now using SOHCAHTOA 2, from SOHCAHTOA 2, I'm giving the cos, which is adjacent over hypotenuse, right? But we know that the hypotenuse is always positive, which means that my x is the one that is minus. So the x is the one that is minus. So now my x is minus 3. That's the value of x. And then y it's unknown. We don't know that one. We need to use theorem of Pythagoras to find that. Then you have r, which is 5. So I'm going to use, before we even answer this question, we need to find y first. When I say r squared, it's equal to x squared plus y squared. Then where there's r, I'm going to put 5. This is 5 squared. And then x, it's minus 3 squared. And then plus the value of y. What is your y? It's what you are looking for, right? So 5 squared, that's like 25. 5 squared, that's like 25. Then 9 squared, and 3 squared, that's 9. So this will be 25 minus 9. It's equals to y squared, which is 16. Y squared. You square both sides, the square root of any number is plus or minus. So y is plus or minus 4. Then that's when you can decide it's y positive or negative. Look at the y coordinates. They are in quadrant 2. All the y coordinates are positive. So therefore, I'm going to conclude and say y is positive 4. So when you have y, then this is when you can start answering the questions. The sign of the sign A, sign its opposite, which is your y. So the answer for this one is opposite. That's 4 over hypotenuse, and hypotenuse is 5. Then you're done answering this one. You move to the next question. The cos A, where cos A is positive, leave your answer in a simplified sat form. They want us to find the cos A, where A is positive. Okay, so if you look at this, they want us to determine where A is positive. You'll understand when do we need to apply this given condition. Eh? Okay, so if I'm looking for cos A, my angle is 2a. So if I say the cos 2a, this is what was given. So remember, this is a double angle, right? So since it's a double angle, we know that the cos of 2a is equals to the cos squared x minus the sine squared x. Let's just use a instead. Okay, so this will be the cos 2a, that's a double angle, is the cos squared a minus the sine squared a. That's the first one, right? And then the second one, that's 2, the cos squared a minus 1, right? Number 3, that is 1 minus 2, the cos squared, the sine squared a, minus 2, the sine squared a. So it's very important to know which one do we need now. Which one do we need? We need to find cos A, and the one that gives us cos A only, because I only need to work with cos, is this one. This one will give me cos A. Even this one, it has cos A, but it won't work because I have sine squared, which makes everything to be more complicated. So I want to choose the easy one. So I can change this and say this is 2, the cos squared A minus 1. So what are we looking for? We are solving cos A. So where there's cos 2a, I can substitute what the cos 2a was given as minus 3 over 5. Are you following? So where there's cos 2a, I'm going to put minus 3 over 5. So this will be negative 3 over 5. And then now this is the 2 the cos squared a minus 1. Let's bring the 1 this side. Let's add the 1, and then this leaves me with 2 the cos squared a. Can you please assist me with your calculator? What do you get when you punch this on the calculator? What is minus 3 over 5 plus 1? What do you get? 2 over 5. So this will give us 2 over 5. 2 over 5 is equals to 2 the cos squared a. Then I'm going to divide both sides by 2, divide both sides by 2. Therefore, the 2 will cancel. This leaves me with cos squared a to be 1 over 5. So I'm looking for cos a, then I'm going to square both sides. Then this leaves me with the cos a being plus or minus the root of 1 over 5. But the condition set, cos a must be positive. Greater than 0 means positive. Then that's when you're going to conclude and say your cos a is positive, the root of 1 over 5. Then that's your final answer. Okay. If I look at this now, leave your answer in a simplified sub form. Is this question simplified? Is this simplified? Do you think it's simplified? Because if I have something like this, I can therefore say this is the root 1 over the root 5, right? Which leaves me with the root 1 is 1 over root 5. Is this simplified now? Is it simplified? Okay, so now another way we can do is to rationalize the denominator. Right? I can multiply top and bottom by that root 5, top and bottom by that root 5. These two gives us the root 5 over 5. Then that can be your final answer. So it's either you can leave your answer on this step, you can just leave your answer on this step, and then, or you can rationalize the denominator. Next question, simplify the following. So we're going to simplify this question. This is for Mark. I need to first do the reduction formula. Right? Okay, so when you do the reduction formula and you see a negative angle, so if I have theta minus 180, you can add 360, right? It's a negative angle. So when you add 360, I don't want this. It's like theta. I'll show you maybe. Let me just do this. So this will be the same as theta plus 180. You understand? So this is the same as the sine of 180 plus theta, which is quadrant. Hmm? Okay, so this will be 0 and 90, and then this is 270, 360. So when I'm adding, this brings me to quadrant 3, you see. So this is quadrant 3, which is 180 plus theta. When I go that side, I'm subtracting. How do I move from 180 to 90? When I say 180, I subtract theta. So 180 plus theta, that's quadrant 3. And then how is sine in quadrant 3? Sine is negative. All students teach comments. Right? So this will be reduced to negative the sine of theta. So I'm just going to write it down here, negative the sine of theta. Do you understand that part? Hmm? You want me to repeat? Okay. Look at this. Remember, we said that if we're moving from this point, we're going that side. You are subtracting, right? And then if you move from this point, you go this side, you add. You understand? Because how do you move from 180 to 270? You add. So now you're going to check in which quadrant it's 180 plus theta. Remember, we changed this from negative angle by adding 360. Then this leaves me with 180 plus theta. So the 180 plus theta is in quadrant 3. How is sine in quadrant 3? Sine is negative. This changes into negative sine theta. Perfect. So you see this guy. This is in quadrant 4. A negative angle, it's always in this quadrant. So tan in that quadrant is negative. So that will change into what? That will change into negative the tan of theta. You understand that part? Then 360 minus theta, 360 minus theta is in this quadrant. So this is 360 minus theta. How is cos in that quadrant? Cos is positive. This changes into positive, the cos theta. Okay, and everything is divided by, now we are working with a 90 degree. 90 degree, that's a co-function. A co-function. Cos changes to sine, sine changes to cos. So I'm going to first say 90 plus theta. In which quadrant is 90 plus theta? Do you know which quadrant is 90 plus theta? Because look at this. No. In quadrant 1, if this is 90, and I go like this, I'm subtracting. How do you move from 90 to 0? You are subtracting. So this is 90 minus theta. Then if this is 90, you go in that direction. From 90 to 180, you need to add. Then that's 90 plus theta. So that's quadrant 2. Understand? And then now, look at this. It's a 90 cos changes to sine. You're going to ask yourself, how is cos in quadrant 2? How is cos in quadrant 2? It's negative, right? So this will change into negative the cos. Oh, this will change into negative the sine, negative the sine squared theta. And then this is how I'm going to write this, right? I'm going to say this is negative, this will change into negative the sine theta. And remember, everything here is squared. The negative will the square will cancel the negative. And then 180 plus theta, that's quadrant 3. Then you're going to say in quadrant 3, how is sine? Sine is negative. Then this will be times negative the sine squared, negative the sine theta, and everything also this part, it's squared. Is this making sense? Oh, this is not a multiplication, it's addition. You see this? you see this part here, it's addition. It's addition, so I need to say plus. So the square root cancels, and then I'm gonna say this leaves me with the top part, negative times negative. It leaves me with the sine theta times. I'm going to change tan into sine theta over the cos theta, right? And then this is multiplied by the cos theta. So on top, the negative cancels. On bottom, I'm left with the sine. I'll be left with, let me, the sine squared theta plus the sine squared theta. So look at this. Cos and cos cancel. Sine times sine, that's sine squared theta. So this leaves me with the sine squared theta on top over 2 of the sine squared theta. So 1 sine squared theta will cancel 1 on top. In fact, no. This cancels this, then this leaves me with 1 over 2 as my final answer. I'm not sure if you want to try the next one. Mhm. So first thing first, we're going to expand the brackets. The top part, that will be the cos 15 degrees plus the sine 15 degrees. So expanding the bracket on top. Okay, everything is divided by what? There's something that I need to do here. If we go back up, you can see that we have a double angle like this. You see, if I have cos squared A minus sine squared A, I can change this into the cos 2 times that angle. So I'm going to change the top part since it's okay, it's cos squared A minus sine squared A, you understand? So I can change this into the cos of 2 times that angle. You understand? So this is what I have. And then on top, this leaves us with multiplying out of the brackets cos 15 times cos 15. That's cos squared 15. Then I'm going to say cos 15 times sine 15. That's sine 15 degrees the cos 15 degrees. So now I'm done multiplying the second term by cos, the second bracket by cos. Now I need to multiply the second bracket by sine now. So this gives me sine times cos, that's sine 15 and the cos 15. Sine times sine, that's plus the sine squared 15. So I'm going to group the like terms. Né? I'm going to group this guy with that guy so that I can substitute it as 1 using the identity. So I'm going to say, oh, before that, let's divide this by the cos of 2 times 15, that's the cos 30. I'm happy because this is a special angle. Né? And then if we keep going down, this will give us the top part. I'm going to group the cos squared 15 with the sine squared 15 plus I'm going to add this to, since there are like terms, this will be 2 the sine 15 degrees and the cos 15. Then everything is divided by that cos 30, and then these two, they give us 1, and this leaves me with the top part being there's another double angle that I see. Remember, if I have 2 sine A, okay, let me write it like this. Remember, this is like saying the sine 2a it's equal to what? The sine 2a is equals to 2 sine a, the cos a. Look at this, 2 sine a, the cos a. So we can write that as the sine of 2 times 15, which gives us 30. So this is 1 plus, this is the cos 30 because of that angle, that double angle. And then everything is divided by the cos 30. And I think on the calculator, when you put cos 30, that's half, ne? Wait, what is cos 30 on your calculator? Cos 30 is root 3 over 2. Okay, I think the mistake is here. This is sine 30, not cos. And what is the sine 30? So this will be 1 plus a half on top over the cos 30, that's root 3 over 2. So the top part gives us 2 times 1, that's 2 plus 1, that's 3 over 2. And then the bottom part that we are dividing with is root 3 over 2, because I need to change that division to multiplication. Say this is 3 over 2 multiplied by the reciprocal. So that these two cancels, this leaves me with 3 over root 3. So I think we can just rationalize the denominator. Ne? So remember, to rationalize the denominator, I can multiply top and bottom. Will this work? If I rationalize the denominator, okay, this works. The top part is 3 root 3 over the bottom part, that's 3. So these two cancels, it leaves us with root 3. You understand that part? Okay.